Hi, I am Lakshmi P. Nair from Saints College of Engineering, Kerala.
And I am Aman Rai from Thapar University. Art project is an image classifier which classifies images into 4 different classes, namely 3D synthesized, natural, retargeted, and screenshots. For this purpose, deep learning is used. Deep learning is a subset of machine learning that is very good at identifying patterns from a large set of data. Deep learning excels at identifying objects in images, given we use multiple artificial neural network layers, thus the name deep neural network. For training our neural network, we feed it thousands of images for it to get better at recognizing patterns in images. This is known as supervised learning. For our objective, we make use of convolutional neural networks.
CNN. CNN is a feed-forward neural network consisting of multi-layer perceptrons. They can acquire and learn significant features from an input at different levels analogous to the human brains. This is also known as feature learning. For unfamiliar problems, we could make use of the feature extraction capability of CNN. By this, we could extract significant elements from already trained CNN with its weights by providing the current input on each level and refine CNN to a little bit specific for that problem. This is also known as pre-training. It helps us to skip training of CNN and saves time and memory. Apart from this, we only need to train the classifiers. Platforms and technologies used for this project are the following. Spider, formerly known as PyD, it is an open source cross-platform integrated development environment, IDE, used for scientific Python programming. And NVIDIA DGX, which is a personal supercomputer designed for demanding AI development. It suggests with a solution that works correct out of the box so that we can implement code in hours than in weeks. Dataset. It comprises of input images for training, validation and testing. We train the classifier using the training set, tune the parameters using the validation set, and then for the evaluation of working, we test using the unfamiliar test set on the model. Total, we have 5128 images, which is classified into 4 categories, namely natural, 3D, retargeted and screenshots, except for the test data.
We tried 3 different pre-trained models for training of a final model, namely Inception v3, MobileNet and VGG16. All these models are trained on ImageNet, which has training data with 1.2 million images belonging to 1,000 different classes. For our training, we used a training set of about 5,000 different images. Firstly, we tried VGG16. VGG16 consists of 144 million parameters, 16 convolutional layers with 5 layers for pooling and 3 fully connected layers with last layer for softmax function. ReLU is applied over all hidden layers. For fully connected layer, it uses dropout regularization. It gave us the training accuracy of little above 63% after 5 epochs. After this, we tried to train our model on MobileNet. In the basic built-in block of this model, the convolutional layer is replaced with depth-wise separable convolutions to save up computational resources. Depth-wise convolutional layer is used to filter the input. Point-wise convolutional layer takes the filtered image to generate new features. Together, these 2 layers form depth-wise separable convolutions, which requires less parameters comparatively. Activation used here is ReLU and a softmax function for prediction. Using MobileNet, we got an accuracy of around 87% after 3 epochs. The final model we tried was Inception v3. It is 48 layers deep and uses multiple layers for fine-tuned classification so that we could retrain the final classification layer to adapt into our problem. Convolution is used for generating feature maps. To reduce computational resources consumed, we employ pooling techniques whose aim is to downsample the input. Fully connected layers are used for classifying the input into labels, trained and softmax function assigned for predicting the output. We attained an accuracy of about 90% after 5 epochs. Out of these 3, we found that Inception is best suited for our purpose. One major reason we chose Inception over MobileNet was the variance associated with the latter. During our training, Accuracy and loss varied a lot with each epoch, whereas there was no such variance while training with Inception.
As Aman told earlier, we choose Inception V3 over other models. It is a convolutional neural network trained by Google using the ImageNet database. Convolution is used for generating the feature maps, and we employ pooling techniques to downsample the input. Fully connected layers are used for classifying the input into label string, and the softmax function is assigned for predicting the output. We select the Inception V3 since it had better performance comparatively. For further processing, we use the model to train on NVIDIA DGX and acquired an accuracy of 97.88%, and we test some of the data. The output acquired over the dataset consisting of 4 classifiers shows that this is the maximum accuracy that can be obtained using the currently available dataset and techniques. For learning purpose, we tried increasing the amount of dataset and observed that the accuracy is improved. My initial dataset consisted of images around 3300, and we further increased it into 5100. The results point out that the performance and accuracy for the model can be enhanced using advanced architectures and by providing large amount of images as input in the dataset. Conclusion. We could conclude that in this digital world, images are encountered daily by a person, ranging from selfies taken from the phone to the pop-up arts in form of images. By doing this project, we could understand the big data nature of images: variety, velocity, and volume. This makes getting relevant information or images a strenuous task. By implementing a deep learning model for image classification, it helps to reduce the manual effort required, and it delivers much accurate results.